shouldn't have an audio source connected so I can say whatever I want, right, guys?
Alright.
Make sure you don't say anything about your coworker.
Rohi, do I teach you?
Okay, you know what? It was funny the first time.
YouTube Studio.
Rohi.
Videos live.
Alright.
Ah, it's working. Cool.
Why are we here?
Why is it unlisted?
That's it?
Yeah, this is the same one.
Damn, where do you think the boss is?
Yeah, this is the exact same one we were already at, Rohi.
Dude, you want to go look for a soccer? Where do you think the boss is?
Not really. I want to go find Cecil. Yeah, this is the exact same one we were already at. Wait,
He's really keen on
I'll summon my own. Get off. Stop.
Alright,
I'll
catch on the
you
flip
these.
side. God, I hate this. Oh man, why does this give me so much anxiety? Man, we normally have like 50 people in the first one. Alright. Is this right? No. Why isn't it full screen? There we go. Is this working? Hello? Do I switch it? Ooh. Oh, okay, no, we're working, okay. Y'all hear me? Yeah? Oh, okay, no, we're working, okay. Oh, it's so weird being able to hear myself. Yeah? Oh. Alright, I guess we'll get started since it's already 6:01. Alright, bear with me here. This is my first time live streaming anything, so a little bit nervous, but I'll do my best. So, if you're here, you are interested in joining the Competitive Programming Club, or you're already a member. So this is kind of our introduction to what we do here. To start, I would like to talk about our legacy, our history. So, this is a little bit embarrassing to admit, but I actually don't know who founded the club, and none of our alumni seem to know either. But I know that this club has existed for about 2 decades, and through those years, we have formed a great relationship with the Faculty of Computer Science, other faculties, and sponsors. We've sent probably 24 teams to regionals and international competitions, and we've trained them in-house with the help of our coaches and a lot of the executive team. It's been a wild journey, and it's been a long one that I'm happy to be a part of. So what we do here is very, very simple. We want to teach you how to program algorithmically. We will teach you the implementations and theory of common and complex algorithms, and provide a foundation for you to not only learn on your own, but open doors that you would not think possible for yourself. And that sounds like PR mumbo jumbo, but honestly, we don't get paid for this. We don't have any inherent gain in doing this for you guys. We honestly just want to teach you the best we can and the things that we think are useful. And we think algorithms are extremely useful for you to know in the field of computer science. So, moving on. Why should you even bother joining the club? Well, there are actually a ton of benefits. You will have an edge. If you join early and you get very into what we do here, you will have an edge in most of your programming courses. And you will gain a confidence in your programming skills that will be unparalleled, like indispensable. You'll just feel good when you program. You'll just learn to like coding. It's a great feeling when you get there. The participation in contests, we post our leaderboards and our contest standings on our website, so there is proof that you've participated in any of our major contests. So you can put that on your resume and it looks great. Employers love that. They will be very happy to ask you more questions if they see that on your resume. We have a number of people who've gone to do bigger and better things, but were executives of the club, and they're at like Google, Amazon, like a whole bunch of other places that sound really fancy. So happy for them, and I'm sure this club played a large part in that. Our contests are scouted by our sponsors, Arcurve and Synopsys. So what that means is we have 2 companies that come by and sponsor our events. We have 2 major contests, ACPC and CCPC. One is sponsored by Arcurve and one is sponsored by Synopsys, but what's in common is both of them look for employees among the participants. So they will frequently hand out jobs that are available within their organizations, and they will be more than happy to talk to you in person. They normally bring recruiters, and they even bring their CTOs and members of the team that I'm assuming they recruit for. But it's a good time, and you can get a lot of opportunities out of that. Moreover, we have a lot of people on our team who have experience in the professional field and also the university, because I guess at the end of the day we're all students. So if you guys need any advice or guidance, we can offer that to you very easily. Like, you just have to send us a message. Send a message to anyone on our Discord within the executive team, and I'm sure they'd be very happy to answer your questions. When you start to apply for jobs, you will face technical interviews, which means that they will sit you down, they'll put a problem in front of your face that looks a lot like what we do here at the Competitive Programming Club. By being an active participant of the club, you will be able to ace these technical interviews, because essentially when they put those problems in your face, you would have had done problems that are harder, and you would have had done probably dozens of problems by the time you face your first interview. So that's a major plus. Moreover, there is money you could win. We host contests We host like 2 major contests with prize pools about like $1 or $2 grand, and we are more than happy to ask for faculty funding to send you off to regionals or even internationals if you get that far. But there's definitely money and adventure to be had in pursuing competitive programming. I guess I've lingered a lot on this, but yeah, you should really give this a try. But I guess I should probably tell you what competitive program actually is. That's probably pretty important. In the simplest of terms, it is the speedy application of algorithms to problems. So you'll notice that right here, number 1, you are typically given a word problem. Now this is telling you what kind of data you have to take in and also what kind of data you have to output. but in word form. In the green here, number 2, you're given an input. And what happens is the code you write has to take in this input and give this output. And they'll normally give you a simplified text version of the input given the numbers that's going to be the number of not the number of test cases, the number of inputs, and also what your output should look like given the inputs. So they'll give you 2 sample inputs and 2 sample outputs typically. So as you can see, you can see that right here. They'll give you a CPU and memory limit, and don't worry if you don't know what that is, I'll explain in a bit. Basically, they standardize CPU and memory so that hardware is not a factor in how well your algorithms perform. So it gives everyone an even fair playing field when they're doing these problems. Down here, you'll see the difficulty. This is normally 1 to 10, with 10 being insanely hard. I don't even think I've seen a question rated that high. But 1 being trivial, round 2 being like not, still kind of trivial, like easy, and then it goes up from there. And they'll also give you sample test cases that you can download and run with your code. So that's very useful. You can find that with every problem that we do with Caddis. Like I said earlier, hardware does not matter. It doesn't matter if you're running a toaster, as long as it's from some year that's over the 1960s, you will probably be able to do these, as well as any hardware you'll find in the modern age. That being said, with hardware and CPU being completely standardized, the factor that separates one competitive programmer from another is how do they handle larger and more complex inputs. So then that naturally brings us to algorithms, which is kind of the bread and butter of what we do here. It does not matter how fast an algorithm solves a problem, it just has to be less than the CPU time limit. So as long as your code can process it in under 1 second, it doesn't matter what your code looks like. It doesn't matter what it does, as long as it works and you can program it fast, just program it fast and get it over with. The implications of having it so that you only have to go under the CPU time limit is that your code can look like absolute trash. Like it could make your eyes bleed every time you think about it. But if it creates the right output, then you are 100% A-okay. You do not have to apply any algorithms that are super hard to implement if you don't have to. So if I have like a 1.2 question that's trivial, I'm not going to be applying, like, if I even can, I'm not going to be applying complex sorting or graph theory to it, because it's like, there's no point. It's going to take me way longer than writing 2 lines of code. Later on, I don't know if you guys have taken anything yet, but you'll encounter ideas like encapsulation, comments. You'll encounter profs that hammer you for code tidiness. That does not matter with competitive programming. You can make it as ugly as you want, but if it's okay to your eyes and it doesn't bother you too much, then you're fine. But with all of those implications, there comes one very important one, and it's that your code has to be under that, which means you have to consider time complexity. So, time complexity. It's a lot simpler than it sounds. Basically, when you're completing any problem, you must consider the type of data and the number of inputs of said data. And that's where asymptomatic, or I always mess that up, asymptotic analysis comes in. Oh my god, it says asymptomatic right there. Alright, that's my bad. Asymptotic analysis sounds complex, but it really boils down to something we call big O notation. Big O, and sorry for the wall of text, I'll promise I'll try to explain this as best I can, but big O is just the time a set of code takes to run as the number of inputs go to infinity. So, to paraphrase that, it's just the growth curve with the time to run